this channel. So in today's video we'll be talking about one-way data encryption, and a very good use case for that is, say you are building an authentication system, and a user needs to sign up, and during the sign up they'll need to like input a password. So you want to like encrypt the password in such a way that it can only be encrypted, it can't be decrypted. So even you, the person that is building the platform or the owner of the platform, can't see what the actual password is once it is stored in database, because it is encrypted and it can't be decrypted in any way, since this is one-way data encryption. So you might be wondering that why. I mean, it is like an authentication system here, so it is the user's password, nobody should have access to it. So even if someone is to break into the database, you listen to be seen as an encrypted password, so they really can't know if the actual password is. So before we get into the video, if you're new to the channel, make sure you subscribe to the channel, and if you're not new to the channel, you've been watching videos but you haven't subscribed for some reason, also consider subscribing. So with that, we'll be using a package in Golang called package Bcrypt. So the package part is golang.org/x/crypto and Bcrypt. Yeah, that's it. Am I spelling this right? Bcrypt. So whenever I see a package that is kind of like X, it means it is experimental. There's a chance that in the future it will come into a standard library, I guess. Because I know I think there was a time that the package context that is not part of the standard library was also in an X package. So I think that X means like experimental or something. But it's actually a library that you can use. So it's experimental does not mean it doesn't work. It works fully well, and it works fine. So to hash a particular string, say a password string or anything, so there's a function called generate from password. So you do bcrypt generate generates from password, and this takes in bcrypt. So this generates from password takes in two parameters: the password, the actual password string, which is a byte slice, and a cost. So I can do slice of bytes. So let me just declare my password now. So I can just say my password should be my secret password. So this will be coming from maybe like, if it's like an authentication system, it's coming from maybe like the input in the password field by a user or something. So I can just pass the password here. Then the second one is a cost. So this cost basically, so if you check the package documentation, so if I do go doc, let me just do this. So if I do go doc bcrypt, there are some costs that are defined as variables in the package, so as constants rather in the package. If I do main cost, for example, so these are basically the three costs: main cost, max cost, and default cost. So you can just pick any of these. So for the sake of this, I'll be using main cost. So I can do bcrypt main cost. Is this capital S? Capital C. Bcrypt main cost. So what does this return? So it returns two variables: a byte slice and an error. So I can do hashed bytes and error should be equals to the result from this. So I'll just check for my error. So I want to print out error hashing password, and I want to get the error, then I want to return. So I actually need to import fonts. So if there is no error, so I can just simply print out the password. So I can format print line hashed password, and then I can print the hashed bytes. No, it is slice of bytes, so I'll convert it to a string. Hash bytes. I guess this is it. So I'll just run this code. So go run main.go. So this is the hash password. So if I run it multiple times, once I want to take notice that for every time I run it, it's giving me different results. So you might be wondering that if it is giving different results, how do we know that all this hash are hash for the same password? Because there's no way we can decrypt it. It is one-way data encryption, so it has been encrypted, it has been hashed, but there's no way we can unhash it or decrypt it. So how do we know that all these hash are actually hashes of the same password? So for that, the library also offers another function called compare hash and password. So this is the password I hashed earlier. So there's another function called compare hash and password. So if I go to, if I just check the documentation, go doc and bcrypt. So this is the function. It says compare hash and password. So I'll just copy that. It's kind of long. So compare hash and password. So this one takes in the hash password, which is a byte slice. So I can do slice of bytes, and I'll take in the hashed password. So basically, this hash password is what will be stored in database when the user has signed up, for example. And when the user wants to log in and wants to do like a password comparison to know if the password that they're entering corresponds with the hash password. So you are not using it to create compare hash and password function. So I can just copy the first hash. So I'll use the three hashes, and we see that we'll always be getting that the hash are actually hashes of the same password string. So this is the hash password. Then the second parameter is the actual password. So I'll just do, and it's also a byte slice. So I'll do slice of bytes. Then that will be this password, which is the password I encrypted earlier, my secret password. Password. What's the issue? Compare hash and password. So what is the issue? Slice of bytes. Why am I getting this issue? Okay, so this one returns an error. So you can just check for the error. If the error is not equals to nil, if there's no error. Why am I getting these errors? Too many arguments in byte conversion. So this is where the issue is. Slice of bytes. This, then slice of bytes. The password. Yeah. So if there's no error, or if there's an error, so you can just do from sprint length. So an error will typically occur if the hash password and this raw password do not correspond. So I can do hashed invalid password. Yeah. Then I can just print out the error, which is now return. Then if everything is fine, I can just from sprint length. So at this point, you can just continue with, say the user wants to log in and you've compared the hash and the password and there's no error, meaning that the hash and the hash is actually a correct hash for the password the user input. So you can just simply from there continue your API logic, maybe grant access to the user or something. So I can just do from sprint lane password, correct password, correct password. So that is it. So I'll just run this. So I'll try for the three hashes and we'll see. So it says correct password. So I'll just simply copy the second hash and it will also be the same thing because they might look different. The hashes might look different, but the hashes of the same password. So it should give me the same thing for the three. So I'll run this also. So it says correct password. Then I'll copy this third hash also. And I'll run it. And I'm still getting correct password. So that is basically it. So for example, if I'm to change this guy to maybe I remove the D, for example. So now I'm putting in the wrong password here. So and I try to compare the password and the hashes. It's telling me invalid password, crypto Bcrypt. Hash password is not the hash of the given password, which is the message we are expecting because this time around the password I'm using has changed. So this hash is no more the hash of this password. So that is basically it. So with that, I'll be coming to the end of this video. If you are not subscribed to the channel once more, subscribe to the channel. If you like this video, drop a thumbs up. Share the video if you want to share to people that you know to be useful to. And also subscribe if you are not new to the channel and you've been watching videos but you haven't subscribed for some reason. So with that, I'll be coming